This is the series in which I'm changing my wallpaper every new episode. So hopefully we don't run out of wallpapers at one point. We are gonna do a couple of things today. Most probably I will put the timestamps in the description if you want to skip to certain sections, but basically I'm gonna spend some time going over a couple of sections of the Structure and Interpretation of Computer Programs book. We will look at some articles and some discussions on the state of tech workers and tech innovations in general. We're going to do some intermissions by playing games, things like that. Hopefully it will be interesting. So let's start. In one of the last episodes, we learned to write general procedures, and I think there's a sum here somewhere. Is there a sum here somewhere? Here. I wrote it by hand. Basically, instead of writing many summation procedures, instead of creating one for adding subsequent numbers or cube numbers or integral derivations or whatever, there's one summation method, one summation engine, and we parameter and we provide all the differences as parameters. But in order to use this sum procedure right here, and we have the method name, we have the term, we have A, we have the next number, and we have B. And as soon at a point at which A is greater than B, we will return 0. And then we do the recursive logic and recursive iteration. We check, we add the term of A with the sum, the same method, of the term of A of the next A and next B. And basically we just call it recursively. But in order to use sum, we had to define procedures, tiny one-off procedures like increment by 4, or compute this weird formula ones, things like this. I think I have somewhere increment by 4. Do I? I don't. Doesn't matter. Oh, so for the p sum or the sum of the cubes. The problem with these procedures, and they're basically just this section here. The problem with them is that they have no meaning outside this one call. They are just a bunch of calculations, basically. They clutter the logic here, and they force us to name things that don't deserve names. So we have a question: whether we can write procedures on the spot. Exactly where and when we need them. And that's why we use something called big we use lambda. And lambda conceptually is an expression that creates a procedure value. We don't declare it, we don't call it, because we won't be able to call it. It constructs a procedure the same way plus 2, 3 constructs a number. Do something like this. Literally, what this does is it creates a procedure of one argument, x, that returns x plus 4. There are no names, there are no side effects. We just get this value. And the difference between define and lambda is the fact that define creates a procedure and it binds it to a name. On the other hand, lambda just creates a procedure. For example, I have here prime plus 4 xx. What do I have? Plus x 4. What I could do here is I can take this lambda and I can plug it inside here, and these two methods would be equivalent. And this basically means that procedures are just values, and providing names is, in a sense, optional. So why do we need lambda? Why do we need it for higher order procedures? So I have here somewhere pizza. I do have, but this is not the p sum that I'm looking for. Maybe I can just add it another color. All right, I had to paste it. I had to paste the image here. Basically, if you see the difference between the p sum that we had above and this pi sum, and the difference between it is that we pass behavior directly as arguments right here. We don't have any extra helper definitions, and the meaning of each procedure is visible exactly where it's used. And this is pretty, this is pretty huge for readability and abstraction. Okay, that's lambda. Basically an immediately evoked and runnable procedure that isn't named, and it's used on the go instantly. Now, which is really good because lambda is also helping us avoid naming procedures. Now, the second role of lambdas is that it creates local bindings. If you have a mathematical function that looks something like this, x 1 y plus 1 plus 1 minus, right? We can actually see that there are some invoking natural repeatable intermediate values. For example, like this could be b, this could be b, this could be a, this could be a squared. And we want to name these. Here it is again. I had to paste it again. Now, what let does is that it's just synthetic sugar. And this section is basically the same as creating a lambda, a and b, and then doing all of these calculations here by hand, basically, plus multiplying x square a by b, ab, etc., etc. All right, so basically, what do we have? Lambda lets us create behavior exactly where we need it. The let is a lambda specialized for local variables. Both have the function in controlling scope and abstraction. All right, so these are basically the foundations of closures, lexical scoping, blah, 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 things like that. Let's do an exercise. Let's do an example. Okay, let's do an example. Let's do an exercise. Let's say we have a procedure and we define it as we define it like this. And then we have this f squared or f lambda b multiplies the sum of b and 1, and this is 6. So what would happen if we would ask the interpreter to evaluate the combination f? So what f actually is, it's a procedure that takes one argument, g, and then calls g with the argument 2. F is named. F is not mysterious. It says, okay, give me a procedure and apply 2 to it. And the first two examples in which we call f square work because we substitute g with the square. So the body is going to become square 2, and we are just squaring the number 2, and it's 4. Now the second case, in which we basically substitute g for the lambda right here, is doing what? Is evaluating to the lambda, in which we have 2's here, so that's 3 multiplied by 2, it's 6, right? Everything's fine, because in both cases, the g right here is a procedure. And that procedure accepts one argument and knows what to do with the number 2. If we try to run this in the case in which we have f and f, where both are the same procedure, this seems like a valid syntax. They are passing a procedure as an argument to itself. So we do this. We call f, and if we substitute g for f, the body will become f2 right here. And f2 is actually a problem. And it means that g is equal to. So the body is going to become 2, and in schema combination like xy basically means call the procedure with argument y. If we have 2, and it's basically nonsense. So the interpreter will most probably throw an error like 2 is not a procedure, or something similar. Okay. Let's do a quick intermission. Let's do something interesting now.